Hello friends, in this video lecture we are going to discuss the interchange of the power between the interconnected utilities. So let us begin. In this lecture, let us discuss how the power is been interchanged between the interconnected utilities. Okay, see basically the term utility, it means that the various firms which are involved in the power system. Okay, broadly we can classify these utilities as generation, transmission and distribution. Okay, again the whole power system, if we consider the power system at a national level, what practically is done in order to have the control over the power system, we divide the system into smaller areas in order to have the better control in the power system. Okay, if we consider the power system of India, so in order to have the control in that power system, what we can have is the distribution of that power system on the basis of the states. Okay, let's say this is one state and this is another state. Okay, let's have one more state. Suppose this is Maharashtra, let's say this is Madhya Pradesh, and let's say this is Karnataka. Okay, now these states, they are interconnected with each other. Okay, now let's call this state as utility. Okay, this will be the first utility, this can be the second utility, and this can be the third utility. Okay, see again we may have different understanding of this term utility, but let us consider at this stage of the discussion the states will be the utilities. So definitely we have some interconnection between these utilities. Okay, now the question arises, what is the purpose of having this interconnection? Okay, we have seen in the load frequency control, while having the control in the two area case, we were regulating the tie line power. Okay, as along with the control of the real power, in order to have the control over the frequency, we understand that when two systems are interconnected with the tie line, then it is very important to regulate the power over the tie line. Okay, now come back to that question, why there is a need of interconnection between the two utilities. Okay, before we understand the requirement of the interconnection between the utility, let us try to understand the different types of the interconnections which are there in the power system. Okay, so first let us understand types of interconnections. See, based on the purpose of interconnection, we may have the different classification. Now, the classification that I am going to discuss here, it will be based on the type of the control. Okay, how we are going to control the power system. On that basis, we can have the two types of interconnection. The first one, we can call it as integrated interconnected system. Okay, and the another is unintegrated interconnected system. Okay, now it is important to understand here the difference between these two types of the system. Okay, in integrated interconnected system, let's say if we are considering the national power system, if we are considering the power system of whole India, in that case, if that whole power system is connected by this mean, that is the integrated interconnected system, then what happens here? The control of the whole power system will be within a particular utility. Okay, and that utility we can call here as a central control. Okay, a central control office will be there, and from that office or from that central control center, the power system or the whole power system at national level is controlled. It is in the case of the integrated interconnected system. Now the controls, in the sense, the control of the generation, the control over the transmission. Okay, so all these things will be there. Again, the different decisions regarding the operation of the power system, addition of new equipment or expansion of the power system, everything, it lies or it will be within this center. Okay, that is nothing but the central control center. Okay, this type of the systems were there in the past. Okay, in the beginning of the electrical system or in the beginning of the power system. Okay, this type of the controls were there, but now these days we are not using that integrated interconnected type of the system. Okay, nowadays you can see normally this type of the interconnection, that is unintegrated interconnected system. Now what it means, as we know that in order to have the better control of the power system, what we are doing, the power system at the national level, we are dividing it into the smaller areas. Okay, so same thing is done here. In case of an unintegrated interconnected system, though all the utilities are interconnected with each other, but let's say for this single utility, for the state of Maharashtra, it will have its own control center. Madhya Pradesh will have its own control center, let's say CC, that is the control center. Okay, so all the utilities are controlled by their respective control centers. Now the question arises, if the utilities are being controlled by the respective control centers, why we are having the interconnection there? Okay, where in case of the integrated interconnected system, we can consider it as this interconnection, we can use it for the control. But in case of an unintegrated system, these two areas or these two systems will have the interconnection based on the different contracts. Okay, this contract may be, let's say, exchange of the power. Okay, suppose there is a deficiency of the generation in one utility and another utility is having the excess generation, then both this utility or both this system can have a agreement, and according to that agreement they may have the interconnection. Again, let's say the Maharashtra state, this utility is having some advanced feature, okay, in order to have the control on the system, and this system, let's say Madhya Pradesh or Karnataka, they want to utilize those advanced systems which is there in the Maharashtra. So for that reason, again, they can have a contract or they can have the agreement. So this way the utilities are being interconnected. So this was the type of the interconnection based on the controlling of the system. Okay, now let us discuss how the power is being interchanged, okay, or the how the power is being exchanged between these interconnected utilities. Okay, so we will discuss right from the beginning of the evolution of the power system, what was the scenario in the past or in the very beginning of the electrical power system, and now what we are having. In that sense, we are going to have the discussion over this. Okay, say practically the power system has major electrical utilities. What we are having these days, they are operating in parallel. Okay, of course we know that most of the things in an electrical power system are connected in the parallel. Okay, again, if I consider the whole power system, basically or broadly, we can divide the power system in three interconnections or three utilities, okay, which are operating in parallel. Okay, so these three utilities or the three interconnections, we can call them as the generation, transmission, and distribution. Okay, so these three large interconnections, they are operating in parallel, okay, in a practical power system. Again, in the very beginning of the electrical power system, the countries used to have one or two major generation and the transmission utilities, okay, with local distribution utility. Okay, so for generation and for the transmission, there was, in complete country, there used to be only one or two major generating station or transmission utility, but a local utility for distribution was there in huge number. Okay, this was the scenario in the very beginning of the power system. But now what challenges has come into the power system is that, see, let us discuss this thing, that is the interchange of the power, in terms of the economical factors. Okay, see, the industry structure is important in discussing the interchange of the power and energy, since the purchase and the sale of power and energy is a commercial business. Okay, that is why, as I said, we will have the discussion in terms of the financial or economical terms. Okay, because what utilities which are involved in the power sector, what they are expecting, see, they are expecting for any transaction, let's say if they are purchasing the energy or if they are selling the energy, what they expect to enhance their own economic position under non-emergency situation. Non-emergency situation means on normal operating conditions. Okay, see, if I talk about the utilities these days, what we have, let's take an example of particularly Maharashtra. For generation, we have Mahajanko, that is the utility owned by the state government. Apart from that, we have the Tata Power Generation, we have the generation from the Reliance, okay, we have the generation from the Adani group, okay, they are also involved in the generation of the electrical power. Okay, so these utilities are there. Again, what happens, sometimes these utilities, they sell their power and sometimes they need to purchase them. Okay, we will discuss where they're having the purchase requirement and where they are having the selling requirement. But earlier, in the very beginning of the electrical power system, for whole country, as said, only one or two major generation and transmission system was there, and those utilities, they were mostly focused on improving their financial or economical position. Okay, normally the marketplace is large, geographically widespread. Okay, let's say for India, we have the marketplace is very large in terms of the electrical market, because we have the very distributed load centers. Okay, so that's why the marketplace is geographically, it is widespread, and the transmission network is the major interconnection which is owned by multiple entities. Okay, now let's say in early days, for if you are considering for India, the transmission network in the British era, it was wholly owned by the central government. Okay, but now after that, what we have, or what the government did, they deregulated the things. Okay, in that case, what happened, the transmission network, state wise, they were given the control over the transmission. For Maharashtra, we have the Mahatransco, that is the utility which is responsible for operating the transmission network in the state of Maharashtra. So transmission network, it is a major interconnection. Okay, because suppose if we are having the multiple states, so definitely this transmission network will be a major interconnection. And as all the interconnections are individually owned by the respective states. So we can say that owners or the operators of those individual transmission networks are multiple entities. Okay. Now, what happened because of this? This led to the development of number of common practices in the interchange of power and energy between electrical utilities. Okay. See, as multiple entities are owning and operating this large interconnection, that is a transmission network. So, because of this, there is a development in the common practices related to the interchange of the power between the electrical utility. Okay, because the transmission network, it plays a very vital role in the interchange of the power. Okay, where this transmission network, it was owned or it is owned by a single entity. Okay, the past and the development practices regarding the transaction. Again, the market structure for electric energy and the power are changing. Definitely, we know that. Every day, the world is coming up with new technologies in all the sectors. Same way, we are having the development in the power sector as well. These days, we are moving towards the smart grids. Okay, so as the case, from the beginning, the market structure is changing as per the coming technologies. Okay, in the past, the interconnected electric utility system dealt only with each other to buy and sell the power and energy. Okay, in the past, this was the thing. Again, only the interconnected utilities were allowed. Interconnected utilities, only these utilities were allowed to deal with each other to buy and sell the power and energy. Okay, but in that case, in the past, occasionally, only for some period, only for some time, non-utility entities become involved in that system. Okay, these days we have the more participation of non-utility entities, but in the past, only occasionally some non-utilities, they become involved in that power system operation. Okay, and what is reasons? Okay, let us discuss that, where the non-utility entities become involved in that power system operation. See, these situations are, these were usually the large industrial organization, which is what we are considering as a non-utility entity, which is having their own generation. Okay, so basically this type of the organization, they involved occasionally in the operation of the power system, or they come into the interconnection. Okay, many of this industry firm had a need for process heat or steam and developed internal generation. Okay, for co-generation plant, for the purpose of the heat process or for the steam and the development of the internal generation, sometime this large industrial organization require the additional power from the external sources. So only for that period, they used to take the power from that interconnection. Only occasionally they were involving in that. Again, sometime, let's say, such type of the large industrial organization, they may have the excess generation. Okay, and in that case, what they do, they sell that excess generation to the local distribution utility system. Okay, so this was the scenario of the power system in the past. Okay, early market only involved wholesale transaction. Okay, the sale and the purchase of the electrical energy to the utility for ultimate delivery to the consumer. Okay, with the exception of industrial co-generators, all the aspects of interchange arrangement were made between the interconnected utilities only. Okay, but you see, in more recent time, there has been an opening of the market to facilitate the involvement of more non-utility organization, consumers, as well as the generators. Okay, now these days, this electrical market, we have made it an open market. Okay, whomsoever requires the power, they can come and have the interconnection, they can take the power, and suppose whomsoever is having the excess generation, they can come to this interconnection and they can sell their power. Okay, this is what we are having in recent days or the present time. Okay, throughout the world there has been a movement towards the deregulation of the electric utility industry and an opening of the market to non-utility entities, mainly non-utility generating firms. Okay, we know that, suppose consider an example of the Maharashtra state. Okay, few days back, let's say in 2005 or 6 before, or 2007 or before, the single utility was there for the control of the electrical power system in Maharashtra, and it was MSEB, Maharashtra State Electricity Board. But after that, there has been a deregulation in the electricity market, and nowadays we know that we are having in Maharashtra, basically the government owned three utilities we are having. One is the Mahajanco, which is responsible for the generation, Mahatransco, which is responsible for the transmission, and Mahadiscom, which is responsible for the distribution. So this is what, because of the deregulation. Okay, again, there is an agitation or the excitation to open the use of the transmission system to all the utilities and non-utility generator by providing open transmission access. Okay, see what this open transmission access it means. Let's say I am sitting in Pune. Okay, and let's say generation is there in Ahmedabad. Okay, we are having a generator in the Ahmedabad. Again, we have the generator at Chandrapur. Okay, let's take these two examples. One generator is there in the Ahmedabad and another generator is there in Chandrapur. Now, this is the load center, Pune. Okay, now definitely some local utility will be there, which is supplying this load in this specific area. Okay, now this distribution utility, it will have the option to transmit the power either from Ahmedabad, or it can transmit the power either from the Chandrapur. Okay, this is just for the example. Okay, practically the scene may be different. Now the transmission system will be there throughout there. Okay, it is an interconnected network. So if I allow the open access to the transmission network, what we can do is, if suppose if I want to bring the power from Ahmedabad to Pune, it can be possible because of this open transmission access. Okay, if suppose if I don't allow the open transmission access, then the utility, it will not have the provision to bring the power from Ahmedabad. Now the question arises, why this utility is looking to bring the power from Ahmedabad instead of getting the power from Chandrapur. Again, we can have the economical issues. Let's say the cost involved in bringing the power from the Chandrapur is more as compared to the cost involved in the bringing the power from Ahmedabad to Pune. In that case, if I give the open access, open transmission access, then it will be easy for this utility. Okay, so that is why this open access was given, or it was given the importance in the power sector with the growing development in the power sector. Okay, again, because of the multiple ownership of the transmission system and the absence of the single entity charged with the control of the entire or even regional bulk power system, there are many unresolved issues. Now, of course, as said, state-wise we are having the different utility or the ownership of this transmission system. So as said, let's say we are bringing the power from the Gujarat, that is the Ahmedabad to Pune. So here the transmission system, it will be, let's say it is being owned by the multiple utilities. We may have the transmission system of Gujarat state. Again, we will have to use the transmission system of the Maharashtra state. Again, in this transmission system as well, the ownership will be multiple. Okay, it is not the single ownership. So because of this multiple ownership of the bulk power system, there are many unresolved issues are there. Okay, so basically what those unresolved issues are, these concern generation control of the flows on the transmission system circuit. Okay, how much power is being flowing on the transmission system, that control is a issue. Generation control is a issue. Okay, and the establishment of the scheme for setting fair and equitable rates for the use of the transmission network by the parties beyond the utility owner of the local network. Okay, see, among these three, that is the concerns which we are saying the unresolved issues, first one was the generation control, another was the control of the flow, the third one, which is nothing but the setting of the fair and equitable rates for the use of the transmission network, that is the important concern in the transmission system. Okay, see, this factor is an important issue since it is the very transmission interconnection that makes the commercial market physically feasible. Okay, now that's why the discussion involved concern over the monopoly practices by the property rights of the owner of various parts of the network. Again, nevertheless, the movement towards more non-utility participation continues and more entities are becoming involved in the operation of the interconnected system. Most all of the non-utility participants are involved in supplying power and energy to utilities or large industrial firms. Okay, see, this power sector is a big market and most of the utilities, they are becoming a part of this interconnected system, or they are involving in this interconnection for the purpose of supplying the power or energy. Okay, moreover, these utilities are the large industrial firms. As said in Maharashtra, if we see, we have the Tata Power Generation, we have the Reliance Power Generation, we have the Adani Power Generation. These are there in throughout pan India as well. Okay, again, the use of the transmission system by the parties other than its owner may involve the willing agreements. Okay, that is an arrangement to use the transmission system owned by another party to deliver the power. Okay, see, these days if you see your energy bill before 2017, this billing charges was not included in the energy bill. Now if you refer the energy bill after 2017, you can see these billing charges are charged to the consumer by the distribution utilities. What actually this billing charges is, what these distribution utilities are doing, they are purchasing the power from the generating utilities. Okay, now they are required to transmit that purchased power to the location where they are having the requirement. Now, so for the transmission of the power from the generating station to the distribution center, they need to have the transmission. And again, this transmission system is owned by another party. Now, these distribution utilities, they are using this transmission system owned by another party. So for that, they are having the willing agreement. Okay, means they are using the network owned by another party to carry out their work. Okay, so there have been willing agreement. Okay, as long as there have been interconnection between more than two utilities. In most cases, the development of transmission services, that is the willing rates, have been based on the simplified physical model designed to facilitate the commercial agreements. Okay, as long as the market was restricted to few parties, these agreements were usually mutually satisfactory. Okay, now based on this willing agreement, the rates have been based on the simplified physical model. Okay, now with the introduction of non-utility participants, there is a need for the development of the rate structures based on the more realistic model of the power system. Okay, see, early days, only few parties were involved in that power sector interconnection, because you see, only few parties were there. So definitely this agreement, it was based on the mutual understanding or mutual satisfaction of those involved parties. But with the introduction of the non-utility participants, so we are having more number of involvements. Okay, early days it was restricted to the few involvements, now we are having the more number of involvements. So for that reason, we need to have the development of the rate structure based on more realistic models of the power system. Okay, again, the growth of the power and the size of energy transaction has emphasized the need of for interconnection agreements on the power flow over parallel transmission circuits. Okay, two neighboring utilities may engage in purchase sale of a large block of power. Okay, see, if suppose if we are having the two neighboring utilities, then for that says what we can have is for the purchase and the sale of the power, these two utilities may be engaged. Okay, let's say those utilities are transmission utilities. Okay, there may have more than enough unused transmission capacity in the direct interconnection between the system to carry the power. Okay, this may be the condition. We may not be using the complete transmission capacity, okay, in the direct interconnection. Okay, so that can be the reason why. Suppose if there is a unused transmission capacity between the connected utilities or the interconnected utilities, so there is a unused capacities left. So if I involve non-utilities to participate in that interconnection, so that unused capacity can be utilized by those non-utilities. Okay, but since the system are interconnected in AC network that include large number of utilities, when the transaction takes place, a large portion of power may actually flow over the circuits owned by another system. That is the another issue of having involvement of the non-utilities. Okay, see, as said, I want to purchase the power from Ahmedabad. I'm a utility operating in the Pune. I'm a distributing utility. I can see that if I purchase the power from, let's say instead of Ahmedabad, let's say if I purchase the power from the New Delhi, from the capital of the country, if I purchase the power from New Delhi, it is costing me less as compared to the other generators which are there in this complete system. So I need to transmit that power from New Delhi to Pune. So what can be the problem in that? Okay, see, between Delhi and Pune, definitely we will have some transmission network, but how the power is been flowing in that transmission network, that is actually been uncontrolled. Okay, so suppose what I am expecting, the power should flow from Delhi to Pune, but there may be a power or the portion of the power which is flowing in that transmission network. Okay, that how it is flowing, that we will understand in the coming section. Okay, again, the flow pattern is determined by physical law, not commercial agreement. As I said, what commercial agreement I'm making, I want to get the power from Delhi to Pune, that is the commercial agreement I'm making. But the power flow pattern is determined by the physical laws, how they are interconnected. Okay, so this problem caused these parallel path flow have been handled by mutual agreement between interconnected system. Okay, so this problem of having the flow pattern is handled by the parallel paths. Okay, again, in the past there was a general if unspoken agreement to attempt to accommodate the transactions, but as the number and the size of the transactions has increased, there have been more incidences of local circuit overloads caused by remote transactions. See, this transaction is nothing but the purchase and the sale of the energy or the power. Okay, many of the problem associated with the transmission system are use of transmission access and parallel path issues. There are consequences of multiple ownership of the transmission network as well. There are structural problems, not physical problem. On the other hand, when a formerly nationalized grid is deregulated and turned into a single privatized network, there are problems. But they are not the problems that arise from the need to treat the multiple transmission owner on fair and equitable basis. Again, you see that area control error that we studied in the load frequency control, inter-utility transfer of energy are easily accomplished. Okay, let us recall the computation of the ACE, that is the area control error. Okay, how we actually get that area control error whenever there is a change in the frequency or the change in the tie line power as per the agreement, then the system gives that area control error. Okay, that we have studied already in the chapter of generation control. A major component of ACE is the scheduled net interchange. Okay, if suppose if there is a difference or if there is a change in the tie line power as per the agreement, then that is the major component of ACE. To arrange for the sale of energy between two interconnected systems, the seller increases its net interchange by an amount of sell and the purchaser decreases its net interchange by similar amount. Okay, in order to have the interchange, what actually is done, the seller, what it does, it increases its net interchange by an amount of sell, how much it want to sell, it will increase that power over the tie line. Okay, let's say here is the tie line, let's say this is the system 1, this is system 2, let's say this is the seller and this is the purchaser. Okay, now it want to sell the power, so what it will do, earlier there is no sell and purchase. Okay, so area control error in that case would be 0. Okay, now as they want to have the purchase or the sell, so what the seller has to do, it has to increase its net interchange by the amount of sell, how much it want to sell, and the purchaser, it has to decrease the net interchange by the similar amount, then only we can have this ACE as 0. Okay, so this way we can have the arrangement for the exchange of the power between the two interconnection. Again, the AGC system in two utility will adjust the total generation accordingly and the energy will be transferred from the selling system to the purchaser. With normal control, the power will flow over the transmission network in the pattern determined by the load, generation, control setting and the network impedances and configurations. Okay, so this is how the power is been interchanged between the interconnected utilities. Okay, apart from the economical aspects of the interchange of the power between interconnected utilities, there are other aspects are also there. So based on that, we have the different types of the interconnection for the interchange of the power, so that we will discuss in our next lecture. Okay, thank you very much.